Well, we're going to look at this example of a Bernoulli and solve it, and hope that will enhance your understanding.
I am so glad.
Well, good. So I hope you can see why it's a Bernoulli. This is dy dx minus y equals e to the x, and here's the Bernoulli part, times y squared. So n equals 2 in this case, and we want to make the substitution u equals y to the 1 minus this 2. So u equals y to the negative 1. So you could say it like this: u equals 1 over y, or similarly, y equals 1 over u. Well, if y does equal 1 over u, then dy dx would be negative 1 over u squared du dx. Just take the derivative of both sides, keeping in mind that y and u are both functions of x, so we got to multiply by the inside function, whatever it may be, the derivative of the inside. So now we want to substitute. Instead of dy dx, we will have negative 1 over u squared du dx from here. Instead of minus y, we will have, remember, y equals 1 over u, so we'll have minus 1 over u. And instead of y squared, we'll have, remember, y equals 1 over u, so we'll have 1 over u squared here. Now we just multiply both sides by negative u squared to get this into the form of a linear first order equation. So multiplying by negative u squared cancels this out, we get du dx. Multiplying by negative u squared, one of the u's cancels, but the other one doesn't, and a negative times a negative is a positive, so plus u equals, multiplying this by negative 1 over u squared, we get minus e to the x. That is a standard linear first order. So integrating factor would be e to the integral 1 dx, which is just e to the x. And so we would multiply both sides by the integrating factor. When we do that, the left side is going to be e to the x times u, but the derivative of e to the x times u, the right side would be, well, I have a sign wrong. It should be minus e to the 2x, because we're multiplying negative e to the x times e to the x. So I hope that doesn't goof me up too badly. I'll fix things as I go along here. Anyway, integrating both sides, of course, we get e to the x times u on the left. And integrating on this side, we get negative 1/2 e to the 2x plus c. That's not too hard to see, I don't think. And solving for u, we just divide both sides by this e to the x. So that would give us, here's another place where I have to switch that sign. There, I think I got it now. So u equals negative 1/2 e to the x plus c times e to the negative x. I hope that looks good for everyone. Now recall, y is equal to, shall we go back and look? 1 over u. So every place where we have a y, we're going to, every place where we have a u, we're going to replace it with 1 over y, because u is 1 over y is 1 over u. U times y equals 1, any way you want to look at it. So u is replaced by 1 over y. Remember, that was originally, we had x's and y's in this thing. We don't want any u's in there. So now we got 1 over y equals negative 1/2 e to the x plus c times e to the negative x, or y equals, here we go with the signs again. I'm fixing it all the way as I go. Y equals 1 divided by negative 1/2 e to the x plus c times e to the negative x. So there we have it solved. We have our constant of integration. If we had some initial values, we could probably find that if it was nice enough. How about that?
I think that this is your way of telling me something.
Telling you how to solve a Bernoulli equation, yes.